Guys, on number 15, it says, which of the following equations would be parallel to the given equation? Remember, parallel means same slope. The slope of this equation is 2. So we need an equation over here that also has a slope of 2, and the only one that has a slope of 2 is C. On number 16, we are naming 3 non-collinear points. Again, non-collinear means not on the same line. So we need 3 points that are not on the same line. If we look at answer choice A, we have C, B, and D. Those are all on the same line. So those are collinear, so that's not what we're looking for. If we look at answer choice B, we have F, C, and B. If we look carefully, F and C are on this line, and point B and point C are on this line. So they are not collinear. So B is our correct answer. On number 17, it says, which triangle congruence postulate best describes the relationship between the two given triangles? Don't forget, guys, that you have vertical angles right here in the center. Vertical angles are not always marked, usually not marked. So you need to make sure that you are remembering that vertical angles are formed when two lines intersect and they're across from each other. So we would call this side angle and side. So SAS is our correct answer. On number 18, it says, which of the following values could be a valid side length for the triangle below? Remember, if we're trying to find the range of possible values for that third side, we're going to add the two side lengths that we have together, and we're going to subtract the two side lengths that we have from each other. So our third side has to be somewhere in between 5 and 19. Remember, it can't be 5 or 19. It has to be in between those two numbers. So our correct answer is D. 17 is the only one that's in between. Number 19, we have which triangle congruence postulate best describes the relationship between the two triangles? Again, we have vertical angles. Vertical angles are congruent to each other. You're going to have to recognize that. Again, they're not going to be marked for you. So you're going to have to recognize those. So we would call this one ASA, or angle side angle. On number 20, we are matching each term with its appropriate representation. Letter A is adjacent angles. We've got two angles that are next to each other. Letter B, these two angles form a linear pair. They form a line. So B is your linear pair. C, these two angles are vertical angles because they're across from each other when we have two lines intersecting. So C is your vertical angles. D is your complementary angles. 50 and 40 both add up to 90. E is your segment bisector. We have segment AC being bisected here by BE. We know it's a bisector because we have our congruency marks here, and bisect means to cut into two congruent pieces. So E is our segment bisector. F is our supplementary angles. We have 45 and 135. Together they add up to 180. So those are supplementary. G is our perpendicular. We have a little right angle mark here. So G is our perpendicular lines. And then H is our angle bisector. We have an angle that's being cut into two congruent pieces. On number 21, you're using the conditional statement below to write the converse, inverse, and contrapositive. And then you're also giving the truth value for each one. So remember your converse, you're going to switch the hypothesis and the conclusion. So we would say if the angles are supplementary, I'm going to abbreviate. Then two angles form a linear pair. The truth value for that is false because two angles that are supplementary do not always have to form a linear pair. They can, but they don't have to. The inverse of our statement, remember again, all we're going to do is make them both negative. So if two angles do not form a linear pair, then the angles are not supplementary. That is also a false statement because they don't have to form a linear pair to be supplementary. The contrapositive, remember, is kind of a combination of both of these. We're going to switch and make negative. So if the angles are not supplementary, then two angles do not form a linear pair. And this one is a true statement. We talked about logically equivalent statements during this unit as well. This was chapter 2. And it says which statements will always have the same truth value. Remember that your conditional and your contrapositive are always logically equivalent, meaning if one is true, the other one's true. If one is false, the other one's false. And your converse and inverse are also logically equivalent. On number 22, it says which definition justifies the following statement. We have the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Anytime we have two angles adding up to 180 degrees, we are looking at supplementary angles. On number 23, we have what is the intersection of the following. The intersection means where are they overlapping or are they running into each other. So we're looking at plane EFGH. So that is the top of our rectangular prism. And we are looking at plane CDHG. So CD and HG. So the part that overlaps is line HG. So that's our intersection. For the second one, we're looking for the intersection of GH and HG. GH is here, and HD is here. So their intersection is point H. And for the last one, we're looking at ABCD, plane ABCD, and plane BCGF. So this one here. The part that overlaps is line BC.